Today we'll be going over in question number 19, remove nth node from end of list. Given a linked list, remove the nth node from the end of the list and return its head. So here in this example, given a linked list 1, 2, 3, 4, 5 and n equals 2, we remove the second node from the end, which here is 4. And we have the precondition that n will always be valid. So how do we start off? Well, we can break this question down into a simpler question. First of all, how will we be able to remove a node given its position within the linked list? So this is not removing it starting from the back, but starting from the front. Well, this is pretty simple. Let's look at an example. We can start off by counting from the front of the linked list. We would have one variable called current, which would represent the node that we are currently at, and we would have a variable called previous, which will represent the node previous to the current node. And all we have to do is break the link between the previous node and the current node and move previous.next to point to current.next. If we do this, then we will be able to remove a certain node within the linked list given its position. Now this question just asks for something slightly more different. It asks to remove the nth node from the end of the list. Well, if we know the length of the list, then we would be able to find the position of the nth node from the end of the list simply by taking the length of the list and subtracting it by n. So let's implement this method in Python. We first off get the length of the linked list, and this is simply just iterating throughout the entire linked list and counting how many nodes there are. So while temp is not none, length would be +1, and we would move temp forward. Now we get the position of the node to remove. Which is just length minus n. For clarity, we would rename it to post instead of n. Now all we have to do is iterate throughout the linked list and remove the node at position post. If post is equal to 0, then we simply return the second node. Now, if post is not equal to 0 and is a node that is not at the beginning of the linked list, then we have to iterate throughout the linked list until we reach position post. We move previous forward to current, and we move current forward to current.next. We can print out current to see what the value is. Then all we have to do is remove the node by setting previous.next is equal to current.next, as we seen here. Previous.next is equal to current.next. And then we return head. Let's look at some test cases. For 1, 2, 3, 4, 5, we move the second node from the end, which is 4. Well, we get a length of 5 and we start counting 2, 3, 4, and when current is equal to 4, Then previous, that is 3, points to 5, which is current.next. Now let's see what happens if we try it with 1, that is, we remove the final node. In our scenario, we remove 5 here. So 4, which is previous, is pointing to current.next, which is none. The last node is pointing to none. That is why current.next is none. And let's try for a value which does not work, such as 0. Remember, counting from the back, 1 is the first position from the back. So 0 is invalid. -1 is also invalid. So for cleanliness of our code, we can actually add in if n is less than 1, we return value error. N is out of bounds. Now let's do 5, which is the very first node in our linked list. Here, we do not even iterate throughout the loop, because post is equal to length, which is 5 minus n, which is 5, which is 0. So if post is equal to 0, we just return head.next. And finally, let's try 4, which is the first iteration of the loop throughout the linked list. So it goes into one iteration of the loop, and it is able to remove second node. So let's submit our code, and it is accepted. Now let's look at the time complexity of this. Well, we go through a first loop where we get the length of the linked list. So in terms of time complexity, that's L, where L represents the length of the linked list. Then we iterate through it again, and we get another L. This time, when we are iterating through it, we are actually keeping track of 2 variables. So it should actually be 2 L operations. In total, we have 3 L operations. And in big O time, this is OL speed. Now, in terms of memory, here we are only keeping track of variables which change as we loop through the iteration. We are not storing any values when we loop through the iteration, which accumulates over time. So the variables that we have are constant, and our memory size will be O1 efficiency. So this is our speed, and this is our memory.